Postfix evaluation, one of the important applications of stack. Like we have seen infix to postfix evaluation, infix to postfix conversion. Next, we have to evaluate an expression, right? So the ultimate chain here is that if you have an expression like this, maybe in numericals, if I have 2 plus 3 into 4 by 2, if I have a mathematical expression like this, first the first step is to convert this to postfix, right? So this infix expression is being converted to postfix, and then we will evaluate the postfix expression to get the output. Okay, so the application here is postfix evaluation, meaning given a postfix expression, how do you find out its value? It means it is a corresponding infix expression, right? So somebody is giving infix expression, it is first converting into postfix and then evaluating it. Okay, so see, we have an expression like this: 231 star plus 9 minus. This is a postfix expression, right? We have to evaluate it and give the answer as -4. I have to find out that value ultimately. I have to find out the value of this expression, right? So we will try to see, but why are we converting to postfix only? Because elimination of parenthesis, easier to implement and reduced complexity. Okay, these three are major important points. That's why we are moving only to postfix compared to prefix expressions. Okay, so given a postfix expression like this, we have to evaluate and find out its value. It means it is some expression, it is some infix expression actually. That infix you have to, that value of that infix you have to find it out. Okay, sorry. So how we do this? Let's see the algorithm, try to understand with an example. We will repeat, we will come and see this algorithm steps. Let's take an example and first see how it is done, right? So we use only one stack here, we will be using one stack. Again, this is a string, it's a string, read each character of the string. Okay, so what you have to do? If the value is an operand, if it is an operand, what is meant by operand? Operator can be any a to z or small a to z or 0 to 9, can means character, right? It can be any operand. So if it is an operand, insert it onto the stack. So I will have a stack with me here. Okay, I will insert the 1 into the stack. What I got here, first character ch of 0, I got as 1. Then I will go to the next character ch of 1. What I got here is I got value 2. So insert that 2 also into the stack. So whenever you encounter an operand, keep inserting it onto the stack. Then came 3, I will insert 3 here. Now after 3, the next character what we are seeing is multiplication. So the first if condition is that whenever there is an operand, insert it onto the, push it onto the stack. Push it onto the stack. Then whenever it is an operator, pop 2 elements, from the stack, pop out 2 elements from the stack. So this will be operand 1, this will be operand 2 and operand. See, first time when I pop it out, I will pop it out, I will get value as 3. So result equal to 2, and what is the symbol here? Into 3 I have to do. Okay, whenever you encounter a operator, okay, whenever you encounter operator, remove 2 top elements, first 2 elements from the stack, top 2 elements from the stack you remove and apply that operator, apply the operator. So it means I have to pop it out, I have to pop 2 elements. After popping, my stack became like this. After popping, I have only 1 element left. So whatever result you got, this result you push it onto the stack again. This you push it onto the stack again, right? So my stack became like this. Next, again iterate over the string. Next one is again an operator plus. This time I encountered an operator plus. What is the logic here? If condition, if it is an operator, pop out top 2 elements, and apply the operation plus, right? So you have to remove 6 and then remove 1. So my stack becomes empty. So apply this, result equal to 1 plus 6, I get value 7. Whenever you get 7, the result, whatever result you get, you again insert it into the stack. So what we are doing here, if it is an operand, if it is a number, insert onto the stack, push it onto the stack. If it's an operator, pop out top 2 elements, apply that operator, the result again push it back to the stack. Okay, next there came 5, next character is 5. So insert 5 here like this. Next came minus. Whenever minus came, what you have to do? You have to again pop out 2 elements, pop out the top 2 elements of the stack. So first element will be 5, then and 7. The result will be 7 minus 5, you get 2. That you insert into the stack, you push it onto the stack. My stack became only 2 now. My stack has only 2. And we have reached the end of the string. Once we reach the end of the string, yes, we have completed the iterating over that postfix string. So after that, whatever is left over on the stack, that is your answer 2, right? So the evaluation of this postfix happens like this, right? Let us go and see the algorithm and then solve another example so that we understand the approach better, right? See the algorithm for scanning evaluating the postfix expression using stacks. Scan the postfix string from left to right. Okay, from read each character from the string. Initialize an empty stack. Okay, create an empty stack. Repeat steps 4 and 5 till all the characters are scanned. So these 2 steps I have to repeat. What is the first step? If the scanned character is an operand, means it's a number or a character, push it onto the stack. Push that onto the stack. Then if the scanned operator is a operator, again there are 2 rules here. Unary operator means pop only 1 element. If it's a binary operator, pop 2 elements. If it's a unary operator, pop 1 element. If it's a binary operator, pop 2 elements. Okay, after popping the elements, apply the operator on those 2 popped elements. Apply the operator on those 2 popped elements, right? Then the result, whatever result you get, you insert it back onto the stack. Insert it back onto the stack, that result whatever you get. Then after all the characters are scanned, we will have only 1 element left on the stack. That is the answer. That element if you return, that is the answer, right? So this is how it happens. But there is one important point to know. Let us solve this example, right? Let's take this example 2, 3, 1 star plus 9 minus. Okay, one small point to be noted here. See, when I insert 2 is when I encounter the first character, it is an operand, I am pushing onto the stack. Then take the second one, it's also operand, push it onto the stack. Take the second one, third one, it's also an operator, push it on operand, push it onto the stack. Then came a operator. Whenever operator comes, I am saying pop out. I am saying pop out. But how will you pop out? See, if I write first pop statement, I will get 3 as the output. If I do second time pop statement, I get, if I write pop first time, it gets 1. Second time when I do pop, it gives me 3. Now, this one multiplication, should I multiply 1 into 3 or is it 3 into 1? Why I am saying about this, suppose this operator was minus. Then what I am saying here, pop out top 2 elements I am saying. First time when you pop, you get 1. Second time when you pop, you get 3. Then apply minus. So is it 1 minus 3 or 3 minus 1? Actually, it should be 3 minus 1. It should be 3 minus 1, right? So we will see that case, it is multiplication. So that's why when you pop it out, you have to take values like this. Value 2, maybe I can take like this. When you write V2 equal to pop, write it like this. Then write V1 equal to pop. Okay, do this way, right? First you take V2, then you take V1. Then you can write result equal to V2 into the V1. V1 into V2. V1 into V2. This way you have to write it. See, the first popped element will be V2, the second popped element will be V1. Then write the expression like this, R equal to V1 into V2. Okay, the meaning is it is 3 into 1, right? So in this case, what will happen here? I got multiplication symbol, I have to pop 2 elements. After popping 2 elements, that is 3 into 1, the result is 3. So after popping, the stack becomes empty. Now this result 3 has to be inserted onto the stack. Then came plus. Again, whenever there is an operator, pop out top 2 elements. So 3 comes, then 2 comes, and we apply plus operator on that. The result we get is 5. So when we are popping out, it becomes empty. So we have 5 as the value here. Next came 9. Whenever there is an operand, insert on top of the stack, right? 9. Then came minus. Then came the operator minus. Whenever minus, it's an operator, pop out top 2 elements from the stack. How will you pop out top 2 elements from the stack? Do one time pop, you get 9. Second time pop, you get 5. Apply this minus on that. The result is minus 4. So you got it minus 4, right? So this is the approach of doing it. If you quickly summarize the algorithm, scan the entire string, right? Create an empty stack. If it is an operand, push it onto the stack. If it is an operator, pop 2 elements, apply the operation, operator, and store the result back in the stack. Do it until you read the entire string. At the end, you will have only one element left on the stack. That will be your final answer. So just pop it out and display as the output. That will be the postfix evaluation. So this is the algorithm of postfix evaluation. We will see the implementation of this postfix evaluation.